Hey guys, thanks for joining me in another video. Today we're going to be going through the topic of chemical energetics in IGCSE chemistry. So this is the relevant syllabus that you should take a look at before I start the video. So the main idea behind this topic is the difference between exothermic and endothermic reactions. Exothermic reactions are reactions that release heat. So that means the chemical energy of the reactants will actually be larger than the product. So overall, there's a decrease in energy because it's lost through heat. An endothermic reaction absorbs heat on the other hand, so you'll find that the chemical energy of reactants are smaller than the product. So overall, it has gained energy. And these two graphs sort of show that quite well. Here is an example of an exothermic reaction where the reactants have a energy level of amount this much, but overall the energy level of the products are lower. So you can see that there's been a decrease in energy from the reactants all the way to the products. Whereas in an endothermic reaction, we see that the products have a higher potential energy than the reactants. So overall, there's been an increase in energy. So therefore, it's an endothermic reaction. So you do need to be able to replicate these graphs depending on whether you're talking about an exothermic or endothermic reaction, and quite often they'll give you the graphs and you are meant to interpret that. Now, one thing that I haven't noted so far is the activation energy. You can see that when you start off the reaction, the energy profile elevates quite rapidly, and the peak of that energy profile to the energy level of the reactants is called the activation energy. So for an exothermic process, it's from this tip here all the way down to the energy level of the reactants, and for an endothermic reaction, it's from the tip of the hump here all the way down to the energy level of the original reactants as well. Bear in mind that the activation energy always has to be higher than the products, so you won't find the peak of the hump all the way down here. It has to be at least higher than the products. And the activation energy, by definition, is the minimum quantity of energy which the reacting species must possess in order to undergo a specified reaction. So I wouldn't overcomplicate things, but the activation energy is basically the amount of energy that is required to start off the reaction. And so they often give you sort of a blank energy profile diagram like this, and you are meant to label or draw arrows to show what or how much the activation energy is. So you should really study these two graphs and know it inside out. So the bond breaking and bond making process is also an important part of this topic. So bond breaking, when you're breaking apart a bond inside a molecule, is an endothermic process. So energy must be taken in order to break the bonds apart. On the other hand, the process of making a bond is an exothermic process, so when bonds are made, heat energy is basically released. So, for example, they often give you a question like this. They give you a reaction, and they say, is this reaction an exothermic or endothermic reaction? And they actually give you the bond energies that you should know, right? So all the relevant bond energies are down below here. So what we're going to do is, first of all, when you are thinking about a chemical reaction, what's ultimately happening is you're just rearranging the bonds from the left-hand side and rearranging that to form other molecules on the right-hand side, right? So by law of chemistry and physics, you can't have more molecules or more atoms on one side than the other because we are simply rearranging it. What that means is, if we were to break apart all the individual bonds on the left-hand side, we should be able to make whatever molecules or the products on the right-hand side. So using that information, let's break apart every single bond on the left-hand side and see what we get. So if you look at the relevant bond energies, we're breaking apart 4 CH bonds, so 413 times 4 is 1652. We're also breaking apart the bond between 2 fluorine atoms, so here it's 158, so 1652 added to 158 gives you 1810 kilojoules per mole. And again, we are breaking apart these bonds, and we talked about the fact that bond breaking is an endothermic process. So in order to break these bonds apart, the system gains 1810 kilojoules. On the right hand side, we're basically reforming the bonds that we've broken in different rearrangements, right? So let's think about what bonds we've made on the right hand side. We have 3 CH bonds in this molecule. So 3 times 413 gives you 1239. We have 1 CF bond in this molecule, and it's got 495 kilojoules of energy per mole. And we've also made 1 hydrogen to fluorine bond as well, which has an energy level of 565. So ultimately, if you add all those together, on the right hand side, we've basically got 2299 kilojoules of energy that's been lost because the process of making bonds, which is on the right hand side, is an exothermic process. So to sum that up, on the left hand side, by breaking apart all the bonds, 1810 kilojoules per mole of energy were gained, and on the right hand side, 2299 kilojoules per mole of energy was lost. So what we now have is that ultimately, if we were to look at it, we've lost more than we've gained. So it's a loss of 489 denoted by negative 489 kilojoules per mole of energy. Therefore, overall, because we've lost energy, it's an exothermic reaction. If we were to have gained more energy than we had lost, which would have been a positive number, then that would have been an endothermic reaction. So I hope that all makes sense. So, hydrogen can be used as fuel, right? So the combustion of hydrogen is a highly exothermic process. It is quite commonly used as a rocket fuel or in experimental vehicles and fuel cells. So the advantages of using hydrogen as fuel is that they are very energy rich and you don't get any pollutants that are forming from it. For example, nitrogen oxides, these things are not formed by using hydrogen as fuel, and because nitrogen oxides are environmentally harmful, that can cause acid rain and things like that, it's overall a good thing that these are not produced. Disadvantages would be that they are expensive to produce and quite difficult and again expensive to store. So let's take a look at the details of how hydrogen fuel cells work. So much like electrolysis, you have an anode and a cathode. Anode being the positive and cathode being the negative electrode, and reactants are supplied to each electrode. So we've got the anode here on the left hand side and we've got the cathode on the right hand side. On the left hand side towards the anode, basically the fuel, which contains hydrogen, is supplied to the anode, whereas on the right hand side towards the cathode end, the air, which contains oxygen, is supplied there. So at the anode, what happens is the hydrogen molecules inside the fuel basically lose electrons and form ions in the electrolyte. And so you have this sort of chemical equation going on, hydrogen becoming 2 hydrogen ions along with electrons that have been lost. At the cathode, on the other hand, oxygen comes in and gains electrons, forming the hydroxide ions in the process. So these reactions are something that you should memorize. And so what then happens is in the electrolytes, you've got the hydrogen ions and the hydroxide ions that react to form water. And that in itself is an exothermic reaction and therefore releases heat, which drives, which supplies the energy, which is the whole point of the fuel cell. So one last point about this topic is regarding radioisotopes and how they can be used as a source of energy. So by definition, radioisotopes are isotopes, which of course are atoms that have the same proton number but different neutron number, that have an unstable atomic nucleus. And so they emit energy and particles as it changes from the unstable nucleus to the more stable form. And over 13% of the world's electricity is actually generated from uranium in nuclear reactors. And nuclear energy derived from this way actually has a fairly long-term nature and therefore sustainable. So uranium-238 are heavier and more stable compared to uranium-235, which is the radioisotope, which is rather unstable. So as uranium-235 basically stabilizes, it emits energy, and that energy can be used as a source of energy. So that's it for today's video, guys. I have been making exclusive past paper tutorials on Patreon, so if you're interested, please check it out and join me. I think it'll be really great help for you. Otherwise, visit freeexamacademy.com, where I write down all my sort of notes for IGCSE chemistry and things like that. So there are some pretty comprehensive notes there that you will find useful. Otherwise, please like, share, and subscribe for extra content in the future, and I will see you in the next video. Cheers.